Hi guys, time for a new video. But before we start the video, I want to make an announcement. And the announcement will be about the frequency of videos I will upload in the forthcoming future. Till now I try to make a video every once in a week. This is in the last weeks got quite a problem because I don't have that time that I had before. As you know, this is just a hobby what I'm doing. It is not a profession. I'm not getting money from that. Yeah. And at the moment, I'm working on a second job. More than my first job is network engineering. The second job is prototyping, electronics prototyping, and both of my jobs at the moment are got a little bit more demanding. Probably because before of Christmas, etc. Anyway, that means that for the upcoming future, the frequency of the uploaded videos will be between 1 week and 3 weeks per video, depending on the time that I have available, because the last videos are getting quite complicated, take a lot of time, and design videos are the ones that take the most of the time. Yeah. Well, this is just what I wanted to say, the information. Let's go back to the video itself. Not many times, most of the times in my designs, I use an enclosure. I use some kind of a display, a rotary encoder, and buttons. And every time I have to make a front panel dedicated for this project. Some time ago, I came to this thing. What I showed you a few videos ago. Yeah. This is an electronic load, but it's not about the load or the functionality about this thing. It is about the form factor and the idea behind that. The whole thing is a small module in a bezel that you can incorporate in a front panel that has a display, a rotary encoder, and a button. And this can be in many different variants. This is one that I already disassembled because I like the idea. This has 4 buttons. So here's the microcontroller, and on this side, on these terminal strips, all the interfaces from the microcontroller on the GPIOs, SPI, serial interfaces, blah blah, you name it, analog, ADC, DAC, etc. is broken out here. That has, first of all, the benefit that you can use this kind of daughter boards, depending on the functionality. For example, this is the electronic load. If you put another daughter board on that, you have a buck converter, boost converter, whatever you want. So, just in a few words, I like this design and I copied it using these bezels. But honestly, I don't, will fall down, but no electrons will fall out, nothing inside. I don't know where to get it. I just find it with modules, with ready-made modules like that. And this is a little bit too expensive to buy the cheapest module in that size and just use it for the bezel. So if anybody of you outside there watch this video and can tell me where I can find this kind of bezels on this size, not on these small 3.5 or 3-digit or 4-digit meters, this is a bigger one. These are bigger bezels. Yeah. Just the bezels themselves, please let me know. So the idea will be to use this kind of bezel and small, cheap, 1 millimeter thick PCB, like it is here, either neutral like that, and we'll use this thing, or such a similar thing that, again, I do not know how I will make it, or just the PCB itself in black with labeling and some kind of foil to cover the TFT display. So now let me show you the TFT display, what I'm using. It is an color 128 by 128 resolution, dots resolution display. If I find anything else that is in this form factor, 1.4, same size, etc., I can use it. It's no problem at all. It's a SPI display. I use the SPI display, SPI, serial peripheral interface, just for to be faster. And the whole thing is modular, like that. This is how the interface, the display PCB will be mounted on the base PCB of this module that I already designed, and I will show you in a jiffy. As you see here, I'm not using any connectors for the PCB, for the TFT display itself, or the display itself. I'm using the flex PCB, the Kapton connector here, directly soldered on the PCB I made. Again, as modular as possible. Everything is in SMD here. And yeah, and this thing is just an adapter that I made with a driver and the 3.3 volt regulator, just we can test this kind of displays on a breadboard without having to use the universal digital front panel board that I've designed. Let me show you now how the design of this front panel board, the PCB, will look. First of all, you see in front of you PCBWay. PCBWay is the sponsor of this PCB assembled PCBA boards that they made for me. Thank you very much. They came out very nice. I will show it to you in a jiffy. PCBWay, I use PCBWay many times. Extremely good results, fast. And to be honest, this PCB assembly, what I received here, is very, very competitive price-wise. Very good parts, exactly the parts that I said that I want. They sourced the parts, and it was in 1 week or something ready. It took longer to arrive to Austria from China because I used snail mail. I used the China Post just to get it cheaper, that's it. Yeah. But again, a nice ruler from PCBWay. Let's open now this box to show you how everything was packaged. This thing is packaged like that. Each board, each ready assembled board comes in an anti-static envelope. And let's have a look at one of them. Yeah, this is now a bit, now I have it. I thought I would have a fight with it, but no, I didn't. So, this is how the boards look, what I received. Very, very nice, very clean. Let's go further. This is the maximum what I can do. Look at these nice boards. Perfectly placed. And it is not only a one-sided PCB board, but a dual-sided PCB assembly. So this is the first time that I'm using from PCBA from PCBWay, and not even a one-sided assembly, but a two-sided assembly. Very, very nice. Absolutely without any problems. I probably will make a video to show how to order dual-sided PCB assembly from PCBWay, a dedicated video. It is, yeah, absolutely nothing. Yeah, if the engineers will find something that is not okay, they will contact you. And if everything is okay, you will get pictures of the first assembled one. And if you say okay again, they will continue to the rest of the PCBs that you ordered. These are exactly the parts that I put in my BOM list and the manufacturers that I wanted them to use. So they didn't substitute anything otherwise, except if I said, okay, I have no problems with this and this component. If you find a cheaper one, substitute it with an Asian one. I have no problems with it. But everything else is completely original. Very, very nice made, original parts. So thank you for this beautiful PCB assembled PCBs, both-sided. Just check the website of PCBWay. It is not only a manufacturer of PCBs themselves. As you can see here, they make assembly, CNC machining, 3D printing, and many other interesting things. And they have, of course, a very nice shop where you can buy modules or other electronic parts, components, etc. And they deliver you things like that. Very, very beautiful. At the end of the video, I will show you a little bit more of how the website looks and what the product portfolio is. But now back to the PCB. The whole thing I will show you in later a little bit more with a schematic. I'm using, as always, an ATMega328, but this time the PB version. It is the successor of the normal P. So the idea is, this is a little bit too far away. Yeah. The idea is to have a generic design that gives you the ability of 4 push buttons, a rotary encoder that I will put up like now. I have to take it out of the bag again. I have everything in bags. Let's see if I can put it behind the camera, like that. Yep, done. This is how it looks. And it is very much similar to this design. The only difference is that I have 3 further push buttons on the left side. On this side, again, I will have the display itself. Here, of course, I will have 3.5 millimeter short connectors, and this will be like that. I cannot work behind the camera. I don't know why. This is how it looks. Of course, without the connectors at the moment, but I need the connectors, so this thing is near to the bezel itself. So this is how it will look from the front, something like that. Naked now, without any cover, any nothing. And then this will be in front of it. So the idea is to have all possible interfaces that this microcontroller gives you on the side terminal connectors. I'm breaking out almost everything. Many, I don't know exactly. You will see it now after that in the schematic. GPIOs, 2 I2Cs, and the SPI, MISO, MOSI, clock, etc. is on this programming connector that again will be with a 6-pin dual connector and can be used from the daughter board itself if SPI is needed. Same thing here. This is a connector for an USB to serial TTL bridge. This can be used either to get natively USB connectivity to this board without any daughter board, or again with an header, female header, that connects on the top of that, on this daughter board that will be made. I can incorporate a USB bridge to. This is the whole idea. So I don't have to every time make a new front panel, and to not every time for trivial designs to make all this from the beginning on a dedicated PCB. I will have it in a module like that, and everything else will be used directly from the header, from these headers that I'm having here. So this is the idea. I don't know if you like it. I like it. And one of my first usages of that will be on a future video. The temperature controller of a hot plate, a cheap China hot plate, PTC hot plate, using this module finished using my design here. So, what else can I show you? Nothing at the moment. But yeah, again, this is one possible daughter board, yeah, and perhaps I will use it as I will make one as a replacement for this load. But honestly, I will not come to the price that you will get the whole thing from China. So probably I will use this design only for new designs that I want to make. Let me show you now how this schematic looks. Okay, this is your schematic. We'll get through the different blocks. First of all, this is the microcontroller block. Nothing really special. Reset connectivity that goes to the reset on the programming header, and on the other side through a capacitor to DTR, data terminal ready, of the USB to serial bridge. You see that I'm using almost everything here what is available, either for the onboard switches here, the 4 switches and the Rotary Encoder. I have an onboard regulator from 5 volt to 3.3 volts. This is for the display and for whatever needed. On the analog side, a small LC filter from the VCC 5 volts digital to the analog VCC, and from there I have an optional reference plant. It is not populated yet. You can populate it whatever you want, whatever version of LM4040 you want, depending on the software design that you make. External oscillator, of course, a ceramic one, should be enough, and the 2 headers, left and right. And you can see here, I'm using the second I2C interface that the ATMega328PB gives me. I'm using both interrupt 1 and interrupt 2 pins. So I'm not using the interrupt pins for any of the buttons or for the encoder. I'm using the dedicated interrupt pins to break them out directly on the headers. Then some other digital I/O. Then 2 ADC channels. That is 4 and 5. That either it is an ADC channel or again an I2C. Yeah, this is what we see here. I'm sorry, that was bullshit. Dedicated IDC channels, 2 of them, and I2C1, I2C2. It is 0 and 1, but that's the first one that is all the ATMega chips have, and this is the additional one that the PB version of the ATMega chips has. So this is more or less how it looks, yeah. And complete ICSP port that can be used, first of all, for programming and can be used as a SPI connectivity, for SPI connectivity. And the FTDI connector that can be used again for an external USB to serial bridge, or just for the use of these 3 pins here for any daughter port that needs it. I will make a second video, I will make a second video on how to configure this thing, how to put a bootloader on this thing, and how to program this thing through normal Arduino IDE, through the normal Arduino IDE. So because this, if I do it now, the video gets too long. And I heard from many people that they do not like too long videos. So I will stop with that. I will show you just a little bit more about PCB, about the PCB website itself. And now the obligatory. Guys, if you like what you see, if you like my designs, if you like my videos, I heard from many people they like it. A few of them said, no, we do not like it. Again, both of you, thank you. Anyway, if you don't like it, don't watch it. Nobody is pressed to do it. But you guys, if you like it, and if you're interested in more about these things, what I'm showing to you, you see that it's a vast variety of themes that I'm showing here, starting from networking, going up to designs, analog designs, digital designs, mixed signal designs, RF designs, up to tubes, high power, power electronics, you name it. Yeah, I'm interested in many things, and everything that is interesting for me, I will show it to you. So if you like it, please press the subscribe button. This will help me a lot. Press the notification button so you can be informed when I have new videos. Even more now that the frequency between the videos gets longer. The time between the videos will get longer, at least for the foreseeing time, for the next foreseeing time. And please give me a thumbs up. All this helps me to show you more. So let's have a look on the PCB website. PCBWay is your one-stop professional solution for everything that has to do with PCB prototyping, including PCB manufacturing, PCB assembly with a lot of features, CNC machining through sheet metal fabrication, 3D printing, again with a lot of materials, using plastic and metal materials, injection molding and vacuum casting. By using the highest standards, immaculate results are guaranteed. So that's for today. I hope you liked this video. This video will almost certainly have a successor. As I said, I will show you how to configure these things, program these things. This will be the second video, and the third video probably will be already with an application with the one that I said will be a controller for the PTC hot plate that I'm using. So thanks again for watching. Please subscribe, give me a thumbs up. Please stay safe, my friends, and see you next time. Cheers, bye.